So here we go. This is kind of a fun lesson. I like the history of mathematics. Did you know that in many places for years and years, centuries in fact, millennia in fact, it was immoral to charge interest. It's called usury. And in fact, in many Muslim nations still, and some Christian nations, but mostly in Muslim nations, it's still considered a sin to charge interest. If you have the money to loan, you should give it to them and not ask for more in return. But that said, it was more acceptable, started to be more and more acceptable in the last 1,000 years, and not coincidentally, E came in not too much after. Now, consider this then. Besides manipulating famous limits, let's also subtitle this. Well, no, I don't want to spoil the fun. Okay, so instead, let's go to a pre-algebra problem. Are you up for a pre-algebra problem? Okay, I feel like actually they're better at their arithmetic than you are because they practice it more. But some of you still have that amazing number sense that you have always had. So check this out. Imagine if you invested $1 at 100% interest, and it was only compounded at the very end of the year. So how much would you get back at the end of the year? $2, okay? Do you agree that you'd get the original dollar back plus 100% interest, which 100% of $1 is $1, so you get back $2. All right, now, if you're a wise investor, you would say, after 6 months, you say, forget this nonsense. I'm not going to wait till the end of the year for you to compound my money. I've been earning interest this whole 6 months. I want you to give me my interest right now. And then he cashes out, and then he turns back and says, now, invest it again for another 6 months. Now, in that case, then, think of it like this. That original dollar, he would obviously get back his whole original dollar back, yeah. But in terms of interest, the interest rate is 100% per year, but you would only get a half of year's worth of interest. And so after 6 months, he would take his dollar and multiply it by 150%. 100% of his money back plus 50% interest. You with me? So after 6 months, he would have $1.50, yeah? Now he turns right back around and says, all right, now I want to invest that $1.50 for the next 6 months, so I earn interest not just on my dollar, but also on my 50 cents. Interest on interest, after all. For that second year then, or that second 6 months, he's going to have 150% of 150%. And so at the end of the year, he wouldn't get back $2. He would have $2.25 because he earned interest on his interest. Are you with me? Okay. Now let's say an even shrewder woman said, forget this stuff, forget compounding twice, let's compound thrice, which is one of my favorite words, thrice. So after 4 months, he has, or she has rather, $1, and doesn't she get all of her money back plus 33% interest for the third of the year it's been in there, yeah? So 100% interest divided by 3. That's her balance after 3 months. And for the next 3 months, she's going to earn 133% on that. And so 1 plus a third of that 1 plus a third. And on the last 4 months, I think I said 3 months, I meant to say 4 months. On the last 4 months, she's going to earn 133% of that. And so interest on the original amount plus the interest works out to be 1 plus a third to the third, or 4 thirds to the third, or 64/27. Will somebody please calculate that for me to 3 decimals? Give me 4 decimals, I apologize. Somebody be my calculator person, please. Two point 3704. Thank you, Jordan. Okay. That's compounding thrice. If you were to compound 4 times, now let's shorten this up. and jump straight to this here. Each time you get 100% of what you had plus interest. And in this case, if you're compounding it 4 times or you're stopping after fourth of a year, then you're only going to get a fourth of 100% interest each time. But you'll get that 4 times, right? That then is 5 fourths to the fourth, or 625 over 256, which is approximately 4414. Now, if they're probably thinking, gosh, man, I am going to get rich if I just keep doing this, because look at that, it's growing. It went from $2 to 2.25 to 2.37 to 2.44. And yes, it is definitely growing. Is it increasing, though, at an increasing rate? Or is it increasing at a decreasing rate? Is the amount of increase slowing down? It is. Okay. At 12 months, how would you calculate how much you had after compounding every month? 1 plus 1/12 to the 12, which is 13/12 to the 12, which is 2 point, what is it? 13? Not 2.13. 613. Okay, 613 what? 0. Okay. If you were to go daily compounding, at the end of every day you compounded your money and rolled it in, constantly getting a new balance. At the end of every day, 1 plus 1/365th to the 365th. That would amount to 366 365ths to the 365th. So Jordan bailed on me, so somebody else. All right, 2.715. Okay. What about every hour? 1 plus 1 over 365 times 24 to the 365 times 24. That's where I will leave it until you calculate. .71 A1. Okay. Now, I think you'll agree that we're starting to get less and less different. We're going from tenths different to now thousands different, and we can get better and better by taking this all the way to infinity. Now, E was around for about 200 years before calculus, so they wouldn't have said limit. They would have just said if you get more and more compoundings, or if you let the number of compoundings grow large. But we could write this as the limit as n goes to infinity of 1 plus 1 over n to the n. And what do we call that? Well, that's E. That's where E comes from. Okay. Now, it's important to understand, one of the things I want you to understand is that, I mean, if there's an island sitting out in the Pacific and people just discovered it for the first time, did people make that island? No, it was there before. Do you agree? Okay, now E and pi. Did mathematicians say, let's make E? Or was it there and people discovered it? Yeah, it was there before people. It would be there after people. E is just a naturally occurring number, just like pi. It's not man-made. It's not like you said, hey, let's make E. It just is, okay? And that is pretty cool, I think. That's where E comes from. One of a couple naturally occurring numbers. Now, there then are 3, I would consider any calculus student worth their salt should have 3 limits they automatically recognize. 2 you've been doing forever. The limit as u goes to 0 of sine of u over u is 1. Okay, that is a famous limit. We could make a table to get there. We could also use L'Hopital, although L'Hopital was way, way after that limit was discovered in the form. Also known as the cosine version. If you take, as u goes to 1, cosine of u minus 1 over u, that goes to 0. Those are famous. And the third, we just talked about. The limit as u goes to infinity of 1 plus 1 over u to the u is e. Now that, to me, is just one more place that calculus is amazing. What did that base go to? 5 fourths, 13 twelfths, 366 365ths. What does that approach to? No. What is the base approaching? It's getting closer and closer to? You're really overthinking. Okay? 5 fourths, 13 twelfths, 366 365ths, 1,000,001 over 1,000,000. That's really getting close to 1. Okay? This is a form of 1 to the infinitely large. Now it feels like, well, that's 1, right? And no, it's not. It's an indeterminate form that we haven't learned yet, but it almost always has to do something with e. The indeterminate 1 to the infinity often results or is tied to an e. All right, now it's that play between the base getting small but the exponent getting large, and between the two they meet and find a number to meet at, and that's e. Okay, now it is important that not only can you use substitute integrals, but you can use substitute in a lot of calculus problems. The idea here will be that you will do limit rules plus use substitution, limit rules plus use substitution to show why the answer is what it is. Not what the answer is, that's secondary. Why the answer. Now, you could surely L'Hopital the bejeebies out of it, and it would work, and it would give you the right answer. That is not the intention. It does not follow the instructions. All right, so let's go, and I will say that L'Hopital wouldn't work in a case we're about to do. You would have to do a use substitution. So the idea goes like this. You're trying to eventually get, obviously, to that, yeah? So we have some manipulating to do. The first might be that the denominators are switched. Now, one thing you can do is to say that that is the same as 1 over the limit as x goes to 0 of the reciprocal. That's a thing that is allowed. Limit rules allow it. And the answers would be the same. Okay? Next, let's let u be what we need it to. Now, the bottom is not an issue. That's not anything I can sweat, because that bottom, that x, I can move 2 out, I can bring 2 in, I don't care. But this, that guy, that I have to be careful with. That is what I need to make my use substitution. You're going to use sub that, because there really can't be any, bringing stuff into the sign argument that, working with the 2 in there. So you got to make that your substitution. Now, surely then, that part of the problem is golden. But just like you sub and integrals, then there's domino effect. You have to replace everything with that. What is 2x then? What does that get replaced by in u terms? 2x would have to be something like 4u. Do you agree? If you multiplied that over x is 2u, so 2x is 4u. So that 2x actually becomes for u. And the limit also has to be changed. If x goes to 0, then u must go to, well, they're directly related. Not a one-to-one relationship, but they're directly related. And so it should be that as x gets infinitesimally small, u also does get infinitesimally small. So the u would go to 0 if the x went to 0. Now that's oh so close. All that's the problem is the 4. Now, a limit rule that is also a thing is that anything that's constant and not in the argument of a function can be moved out front. So that's equivalent to this guy. Well, at that point, I'm golden. That's the famous limit. It's 1 over a fourth, or all right, now, let's talk about how this looks like with manipulating the E part. I look at this, and the very first thing I say is this is like E. So I'm thinking I need to make this look something like this. All right? Now, in terms of what you should substitute, you always want to u sub to make the inside guy. Just like in the previous one, you want to u sub the inside of the function sign. In this case, you want to u sub the inside of the base. So in this case, I would let u, or not u, 1 over u, the x over 2. I'm going to replace that x over 2 with what it needs to be for the definition to be up here. So I'm going to call that x over 2, 1 over u. You follow? All right, that part is great. Now I need to replace everything else. 1 over x. If I wanted 1 over x, couldn't I say that 2 over u equals x? And so 1 over x is u over 2. Now that over 2 is not a big deal. We'll talk about how to deal with that in a second. And what about the last part? As x goes to 0 from the positive side, let's look here. If x goes to 0 from the positive side, then we're talking 1 divided by tiny positive. 1 divided by tiny positive goes to infinity. And so as x gets infinitesimally small, u gets infinitesimally large. And so the limit equivalent would be u goes to infinity from the positives. All right, that is oh so close. The only thing is that over 2. Now, if I could just figure out, I don't have to do this all at once. I could say, what does 1 plus 1 over u to the u do? And then that to the half. In other words, I could split this into, say, what does this part do? And take that result and take it to the half. Now, that is allowed. And that's what gets me my final answer. The inner limit is E, and so what that equals, if I were to bust out my calculator and calculate it, it would actually equal the square root of E. You follow? All right, try the next one on your own, please. Through u substitution, find that equivalence. you get something like this? And so did you get e to the 6th? Yes? All right. Any questions? Okay, cool. That's it. Let's talk questions on set 90. Do you still have 99? Okay, 99. 99. I think 99 had an erroneous hint. 13 said you will need to use synthetic division, and that just wasn't true. I don't know what I was talking about. So, get that. What did you say questions? I'm sorry.
12.
13 and 12? 1. 13, 12, 1, 3, 6.
20.
20. Did I hear 18?
Yeah.
22. Wow. 5. Wow. Right. 13. Okay. So 13, the hint was bogus. Was that the problem on 13, or should we? Or did somebody ask about 13? Maybe that was in my mind. I was talking about 13, I just carried it over. 12, is that a question? Okay, 12, here we go. I don't want this algebra skill to be completely goners. You might have felt like this is mean and tedious to make you do the algebra instead of using the calculus definition. But I have a thought process usually. Okay, so in essence, it's basically not, yeah, I know you know it's the definition of the derivative, and I know you know the derivative is 1 over 2 root x. Show it algebraically. Do you remember how to get there? From here, obviously, like all derivatives, it's 0 over 0 on direct substitution. So your only hope is to tweak it a little algebraically so that the 0 over 0 problem goes away. In this case, you could do that by a lot of different ways. You can factor in some cases. You can rationalize in some cases. And there's some other third method I can remember. But in this case, what applies is rationalize. So we're going to multiply by the conjugate, x plus h plus x minus h over itself. Now the numerator, you definitely do want to multiply it out. It's x plus h, that quantity, minus x minus h, that quantity. The denominator, it does not help you to multiply it out, so just leave it. Okay? In fact, it's counterproductive to multiply it out, so you want to leave the denominator separate. If you then combine like terms, you get the x is dropping out, and 2h in the numerator. That makes the 0 over 0 problem that kept you from direct substituting so successfully go away. At that point, then your 0 problem is a goner, and you have 1 over root x plus 1 over plus root x is. Okay, take you way back to the start of calculus idea. Okay, 12, check. 1. Is 1 still a question?
Yes.
Alrighty. All right. Now, I don't know if your question could be one of two things. It could be the basic, how do I get started, how do I do it, or the more philosophical question. So, is your question, are you asking this question because you don't think or you don't buy the idea that it must be horizontally, vertically oriented? You are the outside the box thinker that's thinking, why can't I do it this way? I guess it couldn't be that big, but How come that's not the biggest area? Or something oblique, you know? That feels like, so, if that's you, that's the kind of Rory Devon question I think that's here. Prove it. Well, I gotta be honest with you, I can't prove that the biggest one isn't oblique. I could, maybe if I sat down and did it for a couple hours, I could prove that the maximum possible area must be oriented so it's parallel to the axes. But I cannot, in the interest of time, prove it. So can we go with the assumption that it's horizontally and vertically oriented and not oblique? All right then. Let's talk the area of that rectangle. It's a base times a height. The base is symmetric in 2x's. The height is some kind of, I called it y, but in retrospect, I feel like y is probably a bad name for it. Could you agree with some kind of difference between the y's, maybe? Okay, so some kind of y. And maybe that's a bad name for it, but you get the idea. If we substitute, what is the y in terms of x's? 9 minus x squared is the upper, if that's what you're looking at. And x squared minus 1 is the lower, I believe. So isn't that vertical distance the difference between the two? With then substitution, or cleaning up, sorry, I get 10 minus 2x squared. So in its cleanest possible form, an equation for area of the rectangle is 20x minus 4x squared. Nope, I am done. 2x, I'm already taking a derivative. That's, no, what the heck am I doing? Do you agree it's 10 minus 2x squared to begin with? And then when I distribute, it's 20x minus 4x cubed. Oui? Okay then. Now I would expect, then we want to maximize. And so I'm hoping for two critical numbers, a negative cube. You can do the calculus of it, but I imagine the max will be at the rightmost x critical number. All right, so find where a prime goes positive to negative. And hopefully it's in the feasible domain. Number 3, here's 3. Okay, 3 is, so this is conceptual. This is pretty great here. This MVT, if no qualifier is given, then you're talking mean value theorem for derivatives. What's the mean value theorem for derivatives, especially graphically? There's a place where the oh, cool. Okay. So I'll come back to that later. All right, good deal. Thank you for telling me before I wasted my time. So that's also on 101, yeah? Yeah. Okay, cool. So 1 of 99. Boom. Thank you for stopping me before I got too far. Okay, so you've got this profit function, and it's a differential question. The profit is 750x minus 2x squared minus x squared minus 99x plus 4,000. I wonder how that works. Use differentials to estimate the change in profit. So it's probably revenues minus expenses. So change in profit if x increases from 125 to 130. Now, we could actually find the true change in profit by finding profit at 130, profit at 125, and subtracting. That's not using differentials to estimate. That's finding true change, which sometimes in life you can't actually find. So differentials to estimate is the practice. We know that the true change can be approximated by the differential change. Now in this case, that's dt. The big idea of calculus is that the change in profit is the rate of change times an amount of change in x, gives you an amount of change in profit. So let's So there, P prime, 750 minus 4x minus quantity, 2x minus 99 at x equal. Now then the next question might be, at which x? 125 or 130? Well, it's at the original. So you're going to do the rate of change at the original point, which was 125. Notice I didn't say the lesser of the points. I said the first point in time. So 125. The delta x is how much we're going to change production by. And it's 5. And is it positive or negative? It's positive because we're changing production by increasing it by 5. So there's a positive. All right, that is going to be your estimate for the change in profit. Something like 750 minus, what is that, 250, 500 minus 250 minus 99 times 5. 250 minus 250 plus 99 times 5. So I'm feeling something like 495. By changing, by making 5 more, we will increase profitability or profit $495. Okay. 6. Question on 6. All right. 6 is. Oh yeah. 6 is stupid. Scratch that. I don't. Yeah, I know it's replacement. My replacement is also stupid. Okay. I don't know what I was thinking. I don't. Sometimes I think I'm clever, but then I'm really just dumb. 20. Questions on 20. All right. Okay. 20. This is a background skill that I gotta get solid before delta epsilon proof, which we're doing tomorrow. Now, I'm looking at some homeworks, and I can't remember if they're 5th or 6th, but some people are going the wrong direction, which is to assume f and prove x. That is not the case. You should start here. If you go with the assumption that x minus 6 is less than a tenth, or better phrased, x is within a tenth of 6 on either side, then it must be the case later as a consequence that this has to happen. All right. Or f, I can't remember what f is, some function. They give you x. Okay, so here's the deal. If I want to get from there to there, then I want to make that x thing look like f kind of thing. And if I want to make that x thing look like f thing, then I need to get that negative 1/3 in there, yeah? But with absolute value. So don't multiply both sides by negative 1/3. Instead, multiply both sides by the absolute value of negative 1/3. Now there are a couple of reasons that you want to do that, but the biggest one is that you do not want that inequality to switch directions. You want it to be less than. And if you multiply by negative 1/3, it will flip directions. So you want it to stay less than. So that's why I'm multiplying both sides by the absolute value of negative 1/3. Not 1/3, negative 1/3. All right. Now we talked yesterday that the absolute value of, or the product of two absolute values is equal to the absolute value of the product. So if I were to rewrite this, it is the same as negative 1/3 x plus 2. I could put those together. Likewise, the absolute value of negative 1/3 is 1/3, and so if I multiplied that positive 1/3 times 1/5, I get 1/3. Are we cool? Now the hardest part, while you're still learning, is how to get from here to here. Well, think of it like this. I want to get f of x here, right? I've got the negative 1/3 x, cool, but I need that to be a 1. Well, I can get the 1 by breaking that 2 up into 1 plus 1. That's totally mathematically allowed. There's no reason 2 can't be 1 plus 1. And that's what allows me to then substitute in negative 1/3 x plus 1 is defined as f of x. So that takes you home. You with me? Oh. 18. Is 18 still a question? Going? By far the big idea is how do you separate the variables here? I think once you separate the variables, you're golden. So somebody that got this, what's a good way to manipulate the right to be able to separate these? Yeah, you could do it that way. Could you also do it by division, e to the 2x over e to the 3y? Either one of those is fine. Do you think you'll agree? So either way, you get e to the 3y dy equals e to the 2x dx. I integrated. And what is the antiderivative of e to the 3y? 1/30 the 3y now, and then 1/2 e to the 2x. Don't forget a c. But after that, I just stopped. They said general solution. They didn't say solve for y. They didn't give you an initial condition to solve for the particular solution. So that's just, I don't know how they wrote their answer, but that's where I stopped. Follow? Okay. 22. Question on 22. All right. 22. Oh yeah, that was a bit more of a humdinger. Now, when I did this similar problem in set 98, I called this distance north, this distance east. I don't think that's good in this case. Let's call this y here and x there. What do you say? All right. They say that the northbound boat is traveling at n miles per hour. So we could say that in calculus terms, that y is changing with time at n miles per hour. And the eastern boat is traveling at 4n miles per hour. So it's the x length, the distance is increasing by 4n miles per hour. So those could be thought of as related rates calculus terms, yeah? They want the distance between the boats is changing 30 minutes later. They want d dt, I define that as d, when time equals 30 minutes or a half hour, yeah? All right, so what's an equation betwixt the variables? Okay, Pythagorean theorem. Lee? I could have found it. Okay, got you. So d dt is 1 over 2 root x squared plus y squared times the inside derivative. What is the inside derivative implicitly or related rates-wise with respect to time? 2x, there you go, dx dt plus 2y dy dt. We could put some stuff in. I think I can factor out a 2 and divide it out. So the dx dt is 4n, and the dy dt is n. Unfortunately, I don't know the x, and I don't know the y, right? All right, that then goes to the instant. I need to investigate this a little more. 30 minutes later, what is x and what is y? goes n, or y style, it goes n miles per hour. So how far will it go, or how long will y be in 30 minutes? N over 2, n miles per hour times a half hour, so n over 2. And how long will x be after a half hour? 2n. Okay, so feels like then we're talking, substitute x is 2n, y is n over 2, 2n, n over 2, just n's all over the place. So we get 8n squared plus n squared over 2 over, shucks, I did it again. 4n squared plus n squared over 4. So up there I have 17n squared over 2. Down there I have 17n squared over 4, all square rooted. So 17n squared over 2 over root 17n over 2. All said and done, the 2's drop away, an n drops away, and I have 17n over root 17. How do you feel about that? Okay, cool. That's miles, right here. Nope, that's miles per hour. Okay. 18, that was 18? Is that 22? Okie dokie, 5, is 5 still a question? Okie dokie. 5, 5, 5, 5, 5. Okie dokie, they tell you velocity is t plus 1 over t. They say the position at 3 is 5, and they want the position function equation. So, we'll integrate this. Did you write this as an integral defined function, or did you write this as a plus c kind of case? Plus c case. Cool. Okay, so the question then becomes, how are you going to integrate that? What's the technique? Split it. Yeah, split it is the easiest way to go. You could use sub and do lots of stuff, but that's the easiest way. So you probably overlap. Ultraviolet blue might work, but it's maybe opaque. Okay. Oh, it could be, yeah. Yeah. If ultraviolet voodoo makes an easier integral. Okay, and that works. Okay, questions? Nope. All right, 99 is in the books. Turn it in. Turn in 99. Turn in 99. Are you bringing cans to your third hour? A race? A race? In cans? So for two, it's supposed to be 45. And I'm trying to think of where the school would drop out. I don't really know. You want to I got it. Let's see. I bet it's a diameter thing. No, oh yeah. See, it says the diameter is 50 centimeters, so the radius should be 25. Before you get there, before you place.
I was having
People
trouble
are
setting up
trying more.
that.
Here for sure. Maybe you're set. I agree with parallel to the y-axis.
The answer was different. It was like 4 something. Thank you, Mr. Eichner.
You're welcome. Have a great day. Thank you. Number 4. Very good. Now you typed in your calculator. It's set up properly. Okay. Maybe you know. I say maybe you typed calculator for that one, maybe. Yeah. Well, maybe you did. I don't know. They works good.